Hello, my name is Justin Upham, and I work for the University of Wisconsin Extension as a state specialist for environmental education. I'm also the director of Upham Woods Outdoor Learning Center in the Wisconsin Dells. Today I'm here to introduce our Value of a Tree kit and lesson. This was originally published by our team in 2014 in Science Scope, and when it was published there, it was intended for a national audience. What we've done here is place this kit into a lending program where you can check it out, and we'll mail you the tools you need to execute this project.
This homemade clinometer is made with a protractor, a straw to sight the top of the tree, and a string attached to a heavy object to keep the string taut to determine the angle between your eye and the top of the tree. To begin, form an imaginary triangle between yourself, the top of the tree, and the base of the tree. Measure a distance from the tree using measuring tape from where you can clearly see the top of it. Once at that point, sight the top of the tree by looking through the straw piece of the clinometer. Another person will have to tell you the angle that the protractor reads using the string. It is important to remember to subtract 90 from the angle that was read on the protractor. The reason for this is because the angle of the clinometer when directly horizontal is 90 degrees. And so, as you look upwards, the angle your protractor reads will be greater than 90 degrees. Once you determine the angle from your eye to the top of the tree, you can utilize some basic trigonometry to determine the height of your tree. Use the tangent function on a calculator to do this because you only know the adjacent side length, which is your distance from the tree of the imaginary triangle that you formed using the clinometer. You will need to multiply this distance by the tangent of the angle of elevation. This will give you the approximate height of your tree. It is important to remember to add your height to eye level to this calculated tree height to obtain a final value. Now that we've learned to use a clinometer to measure the height of the tree, can you think of any other uses a clinometer might have? Would you believe that this tool was used in World War I to help aircraft pilots navigate through a storm?
This project was funded through 2 grants, one from the Wisconsin Environmental Education Board and one from the USDA in the form of Northwest Advanced Renewables Alliance, the NARA grant. The materials you see here were developed by team members, teachers, student feedback, and staff at Upham Woods Outdoor Learning Center. You can learn more about this material and our other lending kit projects, as well as grab-and-go lesson plans on our environmental education website. Thanks a lot.